Welcome everyone to the fourth in our webinar series, Retrofitting South London. This webinar will be made available on our website, retrofitskills.org, if you'd like to pop over there and have a look at our resources page where you'll find our whole series. The aim of this series really is about building the knowledge, awareness and understanding of retrofitting buildings. So we can start to improve energy efficiency and reduce our carbon emissions. It's complex. We understand the term retrofitting is sometimes difficult to understand and interpret. So we're hoping to break some of that down by speaking to different people and different players who are really influential in the retrofit world. In South London, we've got over 635,000 properties that require some sort of intervention to make them more efficient, more energy efficient, and less leaky. And we talk a lot about leaky properties across the country, but particularly in London, and how we tackle some of our housing and commercial building stock. Our research has anticipated that we'll require more than 66,000 person years by the trades to complete the interventions required. So how we do that and the incremental steps to ensure that our buildings are more energy efficient is really, really important to us. And it's important that we start thinking about how our buildings can be reimagined, be redesigned to make sure that we meet some of those carbon emission goals that we have set across South London, London and the UK. We're really excited today to hear from Matthew Goldschmied, from RVI Architectural Design. Matthew joined us for the Retrofit Summit that we held in Merton back in May. And he delivered some inspirational talks and speeches to our future talent pipeline. So over 150 school students across South London. We're really focused on thinking about how we develop our skills and our talent, but also how our young people start to think slightly differently about construction, engineering and the built environment, and what future careers might look like, particularly within these industries, and the impact that they will make on our environment and our sustainable future. Retrofit will become part of our common language. It will gather momentum, we anticipate, over the next few years. So it's really important that we speak and listen and hear from people like Matthew, who have lived real world experience of delivering these projects, but also has some really good expertise, knowledge and understanding to help us think about good design and retrofit and what we all need to do to get started. So without further ado, I'm going to hand over to Matthew, who is truly the expert. There'll be opportunities for questions at the end of the session, and please do save those up and think of those, and we'll come back to Matthew. But thank you so much, and we'll hand over to you.
Thank you very much indeed, Polly. I hope you can all hear me. Well, that's quite an introduction. I've got something to live up to now. So I'm going to share my screen and get started with a presentation about, I hope you can all see that. So I'm going to give you a talk about retrofit, and really it's a personal perspective derived from years of experience of dealing with buildings, not specifically as retrofit early on in my career, but dealing with conservation, which is what I studied after studying architecture at university. So we have a lot of buildings in the UK, and by 2050 we're still going to be using most of them, and approximately 90% of our current existing homes will still be in use. Now 5.9 million of those, give or take, are pre-1919, and that's an important date which I'll refer to later on. So we've invested a huge amount of raw material into creating these townscapes. And it's sensible that we salvage and reuse as much as possible, and that really is the reason for retrofit. And retrofit needs good design. So what is it? It's adding something new to an existing thing. It's usually adding something to improve the performance and function, but it's a fairly dull word that describes an important ambition. And this is my understanding of what retrofit is. It's to enhance the experience of everyday life for human beings through good design and considerate specification. But it's bigger than just the performance element of a building. There are real world implications, the benefits to society and human beings in general, through improved health, comfort, security, stability, and economy. There's a whole range of things we can improve in terms of everyday life for the citizens of the UK and beyond. But it relies on good design, and design is more than just a great Instagram picture. Now, here's a great Instagram picture. There's a reason for it. It's retrofitted with an electric engine. Here's one of my projects down in Hampshire, which is a retrofit to improve efficiency and comfort and use of the building for long term. So good retrofit requires selecting, coordinating, and installing materials and technologies into a building that enhance people's lives for long term. Now, without good design and skilled installation, we're not going to succeed in a nationwide retrofit program at scale. And we'll see continuing fuel poverty, risk of mental and physical illness, ecological degradation, and likely social instability. Here's a retrofit, not one that I would recommend. So let's not be this guy. And here's the building equivalent to this kind of approach. It's disaster and it's misery. So if we don't address these design challenges and the management of projects effectively, we're going to end up with a lot of failure within our retrofit industry. So here's an Italian word from my heritage, which is rivivere, and it literally means to live again or breathe new life into. And this is where RVI, architectural design, is derived from. Now, I've been lucky enough to work on some of these projects over the years, and they're all quite dramatic and they're meant to be because they're for my website. But they illustrate the hardest types of building to treat, which is traditional buildings. All of those are pre-1919. So breathing new life into existing buildings and enabling people to thrive, feel safe, and live happier lives. Now, we design with sustainable materials as far as possible, with renewable energy systems, controlled ventilation, and high performance fixtures. But most importantly, we're designing for people. We're always recognizing that we can improve the quality of existence within buildings through the retrofit measures that we install. This people-centric philosophy is designed for long-term benefit of the built environment and the people using it. And it's important to note that retrofits more than just renovation or refurbishment. Often projects start as a renovation and they turn into a much broader scope of works to develop a retrofit program for the whole house. So design is always important, and it's most important in traditional buildings, which are the hardest and riskiest to retrofit. So where do we start? Well, we start by analysing what we have, the current state of the building, the performance that it currently has, and where we want to take it. A word of warning, watch out for your EPC. It's not quite telling you the whole story, and we'll come on to that in a bit. So most UK houses, it should be noted, have been through a number of retrofits. Think of all those fireplaces which were taken out because coal was no longer the fuel of choice. Gas central heating became the norm. And it's now gas central heating that we're trying to migrate away from to electrify, to reduce our carbon emissions. And it's important to understand all of the history of a particular building and seek an optimized retrofit. And the most important thing is that we balance the risks that are involved when you modify the fabric of a building. But we also look for the constraints, how we can help the client, the homeowner, to operate within their parameters, and the opportunities for them and their improving their lives. So we take a whole house approach, and I add to this that it must be context appropriate and people centric. Now, when we turn up at a building that needs some help, we encounter all of these kinds of issues, and I'm sure you're all familiar with them. If you've ever lived in an old house, you'll recognize at least one of them, I'm sure. So what is a whole house retrofit? Well, it requires optimizing and balancing three crucial interdependent factors of heat control, air tightness, and moisture management. Now, only a whole house retrofit can achieve this balance. If you focus on one, you're going to lose track of the other, and you'll probably have some unintended consequences. So we try to design all of our retrofit work to be phased, and that suits the constraints of the particular circumstances. So that design ensures that we're not causing any harm or preventing future retrofit interventions further down the line. And we're going to look at a few examples because we haven't got that much time. So overheating, it's one of the most overlooked of the key issues that we try to address. And in July 22, we had record heat temperatures, and during that year we had record heat-related excess deaths in the UK. Here's a fire in Croydon. That red circle is my house. So it was brought pretty close to home back then. And in that same year, I've spoken to a client recently, and I've done a bit of work on this project here. This is in Carshalton, just down the road. 10-year-old Sam literally couldn't use the bedroom on his top floor, which I don't know if I can use the cursor. That's his room there. It's got a small roof light on top, a small square window at the back. It was due to their constraints, they couldn't actually do the full extension project they wanted. And so what they ended up with is a 6-year-old extension that was actually failing to protect the occupants inside, basically, which is what you expect a house to do. So we had to analyze what was going wrong. And the analysis, we essentially built the house in the virtual world, and we analyzed how we could modify it, extend it, and improve quality of life for the occupants going forward. So here's the main problem we discovered: the material that was used to insulate the property. It's PIR. You're probably all familiar with it. It's the most common, accessible, best value insulation product around. And in pursuit of U-value performance, or thermal, its thermal transmittance, it's fantastic, and it can meet building regulations. So why wasn't it actually protecting the people inside the house? As approved and specified, it passes U-value, meets building regulations. Here's a bit of science that tells us that its heat phase shift, 9.3 hours. Think of it this way: sun comes up at 7 a.m. 9 hours later, that insulation has failed to stop that heat penetrating right the way through to the inside face of the building, in this case, a bedroom. So what could we have done differently? Well, if we'd specified wood fibre insulation, for example, same construction, same depth, it fails building regs. However, it would shift the heat protection to 14.7 hours. The reason for that is wood fibre insulation has a far higher thermal capacity, or heat storage capacity. So we're not going to go ripping out all of that insulation that's in there. It's encapsulated in the ceiling. We're going to simply retrofit a new layer of wood fibre insulation on top of the existing roof plane and create a new flat roof, along with some other modifications to the windows and ventilation and so on. But this illustrates very simply how applying a scientific analysis to an issue can come up with a very simple solution. And this is through ecological building systems. This demonstrates, the one in the middle is wood fibre. The temperature on the lower line is, after 15 minutes, how much the insulation has heated up. If you look at polystyrene, 42.6, wood fibre 24.7, mineral wool 70 degrees. That illustrates the level of protection. The top number is the essentially the external air temperature, or the heat of the lamps in this case. It shows that designing and specifying appropriate materials can get you the results you need. Going with the convention, slavishly following building regulations as the minimum standards, is not going to get us the results we need. So that's one reason why PIR is not appropriate, in my opinion. It can't cope with those extremes of climate. It's a petrochemical byproduct, which I don't particularly favour. It off-gases high-risk toxins into the home, and the manufacturers claim it's inflammable enough to be safe, so we can sleep easy, aren't we? So, what alternatives do we have? Well, I favour environmentally resilient materials that are better suited to human beings and traditional buildings. By traditional buildings, we mean those built with solid walls rather than cavity walls, because the building physics dynamics are so completely different that we have to apply different methodologies to it. So alternative materials such as these can manage heat and moisture and air far better than any of those plastic petrochemical materials. And they're also non-toxic whilst being installed and non-toxic to occupants. So here's a project I'm currently working on. It's reviving an old parish hall down in Sussex. And this page that I'm showing here, you don't need to read it all. It's part of the design and access statement for the planning application. And that's important because we need to know in advance how we're going to treat this building before we even apply for planning permission, because we may need to make external alterations which will affect what we need to apply for. So very briefly here, we're retaining the blue building down in this diagram, which is 1870, the original parish hall, and the two 1920s additions, which were a school room and a cottage for the schoolmaster. Those are being retained, and then the red pieces are being deconstructed. I try not to use demolition because deconstruction, it shows that we are trying to salvage and reuse as much of those materials as we can. And we will be using a lot of the materials we salvage from those deconstructed elements. So this presents us with a challenge as to how we're going to deal with the 1870 building, which is solid wall, the 1920 pieces, which are cavity wall, and then the new extensions we're going to add on the front and at the back, which will be a cavity wall as well. So this all starts with people-centric design. It's considering that flow of an interaction of space, of light and heat, moisture, sound, and over time, how the building can be adapted for use in later life. For example, when mobility issues might become a factor of life, how can the spaces be adapted to accommodate a live-in carer or to accommodate the occupants being able to live independently for longer in their homes? All the while, we've brought this into a whole house retrofit plan, which then will have extensions added to it. Now, this is an illustration of just the insulation strategies that we need to employ for this building and this site. I won't go into too much detail on where the complexities lie and why there are complexities, but needless to say, we need to know exactly where those complexities are, and we need a plan for each junction, where each element meets, with each new element meets an old element. We need to know what the building physics are going to mean for the insulation strategy we devise. So here's a detail, just one of the approximately 35 details that we're going to be developing for this project. And it's important to note here, I'm going to introduce the term of optimum, not ultimate performance. And that's something we have to apply to traditional buildings, because ultimate performance would mean we have to hit minimum building regulations, which in some cases we can't. It's just not practicable to do. So we're balancing performance, complexity, and of course, the very human constraint of cost. We can't just specify everything and say that's what you have to do. We have to balance around the entire site how we're going to fit all of this within budget. So whilst this doesn't quite meet building regs, it is a performance upgrade of approximately 6 times over the existing brick wall. And another important principle is that continuity of insulation is far more important than ultimate U-value performance. So that's one illustration of how we go about a retrofit project. Now, renewables, you're probably all familiar with solar PV and aerothermal heat pumps, commonly just called heat pumps these days. which there are grants available. And it's interesting to note here, I've put the graph of the cost of solar panels over the last 50 years or so, over $100 a watt back in 1975, down to about 20 cents now. So it's a very accessible, brilliant technology that can help us transition very quickly to a much more electrified built environment. Heat pumps can do the same, but we're not quite there in terms of the levels of installations. 37,000 or so last year, yet we still installed 1.5 million gas boilers. So we've got some work to do. Heat pumps, approximately 400% efficient. Gas boilers, never more than about 90%. High temperature heat pumps, they may be useful. I'm not going to go into a huge amount of detail because I don't really have the time to check time. Yeah, better move on. In the New Forest, I was involved in the project over this 4-year period. There is a BBC documentary on the early stages of this project, which you can look up on YouTube if anyone's interested. Essentially, this site is about the equivalent size of 4 to 5 normal houses. So it's more like a district heating network. But the ambition was to transition away from burning 10,000 litres of oil a year, which today would cost £7,500 and emit approximately 30 tonnes of CO2 equivalent emissions. So there was a design and coordination of a retrofit plan before I'd ever even heard of the word, which involved wool and cellulose insulation, draft proofing, hybrid energy systems using biomass, solar PV, solar thermal, and geothermal. Now, geothermal is a ground source heat pump, and this illustrates the 6 90-metre deep boreholes that were drilled to feed into the heat pump system within the site. So following that, CO2 emissions are cut to approximately 4.5 tonnes. And that's further reducing as the electricity grid decarbonises, and we're up to last year, about 50% renewables, up from 10% only in 2010. So there's a lot to be optimistic about. Now, we just have to focus on that priority, which is people. Now, this is a project down in Croydon that I'm working on. It's in a conservation area. Either side of it are listed buildings, and it's a very elegant and generous conservation area. Street, nice and wide, detached houses predominantly. And so this is a plan that recognises the constraints that the homeowner has according to their budget and the logistical complications that are going to be involved in renovating this house and building a new extension. Bearing in mind he's got 6 children, so all of school age. So we've designed this to accommodate the human constraints that exist in this particular context, and it's designed and going to be implemented in these phases that will allow them to maintain a relatively normal life. So that's just one way where human constraints actually dictate our design approach, not just in terms of what it looks like, but how it performs and how we can actually install all the things which need to be installed. I'm going to quickly touch on ventilation because there's this mantra which is insulate tight, ventilate right. And that is absolutely crucial because moisture management in buildings is one of the well, for years, it's been underrated as a key consideration. In fact, my own house here, I know the limitations of the ventilation systems that I have. If you want the ultimate system, you need someone with real expertise to design it. And that would be a mechanical ventilation heat recovery system, which essentially takes stale, damp, humid air from bathrooms and kitchens. It captures all the heat that's within that air. It draws fresh air in from outside, transfers that heat into the fresh air, and then ducts the fresh air into habitable rooms such as bedrooms and living rooms. It's costly, disruptive, but it is the ultimate, and it's what I want to do here. I'm actually investigating, and you can see behind me, this is a chimney breast here. which isn't in use anymore, I'm investigating using that as one of my key risers, basically, for a to install ultimately an MVHR system. Going down the scale in terms of cost and complexity, we've got decentralized MVHR, which essentially is independent heat recovery extract units, which can go in different ends of one floor of a house, for example, and they can talk to each other to manage the flow of air whilst also capturing the heat that is being extracted. And then what the most common that you probably all have is an extract in your bathroom, one in your kitchen that will extract nasty air whilst drawing in fresh air. So it's important that we address those issues, and I'm not going to go into a huge amount of detail on it because it's so context specific that it's just part of the design process that we have to go through. So a quick look at a homeowner I encountered with a budget of £30,000 who got a retrofit assessment done by a very reputable surveying company, which takes the EPC metrics of the home, and ultimately it tells him he's going to have to spend, you add up the figures in the red column on the bottom left, £143,000 plus VAT, plus consultants' fees, plus all the other costs associated with it. So it's completely impractical for him. And it's important to note that Which issued a policy paper a few months ago, which says this: EPC doesn't reflect the actual performance of the property. It is based on assumptions. I've been talking with peers in the industry for years about this, and there are changes on the horizon that will make more accurate reporting through EPCs the norm, but they aren't with us yet. So those kinds of numbers are impossible for him to afford, because it illustrates an ultimate rather than an optimized plan. The optimized plan recognizes, or should recognize, the homeowner's circumstances. And we're helping him to figure out what he can do, to empower him to see what would be appropriate and most effective for him to do. The cost savings against the cost estimates to install, they just don't stack up. So overcoming this in action. We've designed a series of small illustrative guides specifically tailored to the details of his roof his roof space, which he wants to start with. He used it as a room and roof, and there are also eave storage areas. So there are different complexities that need to be addressed. No way could you do this without visiting the property, poking around, taking photos, understanding what's really going on, how the roof is constructed, etc., etc. So this is the best we could do for him, and he can then work with a local handyman, and he can DIY some of the tasks himself, and he's already started doing that. So I'm hoping, and there are people I'm speaking to about developing these, utilizing this resource of enthusiastic, competent DIYers who want to just get stuck in. And there's plenty of opportunity to do that, but everyone needs to know the design is appropriate, and that's where I'm helping some people in that respect. So quickly on finance, if you want to get a new kitchen, you could go out this afternoon, go and get £20,000, install a fancy new kitchen, and it presumably is because it increases value, it's easy to go and get finance and easy to justify, etc., etc. So does retrofit increase the value of your home? Well, according to Knight Frank, it does. They say these kinds of numbers, this was a couple of years ago, but these kinds of numbers are starting to filter into the thinking about valuing the asset. But not everyone owns their home, and not everyone is looking to sell their home. So where do they find finance? If they don't have it in the bank already, there are products that are coming to market, and that's evolving pretty quickly. And I'm in touch with a few specialist brokerages who are looking to fund retrofit projects specifically. But they will all demand that the design is appropriate. And I think I'm just going to leave it there because hopefully that leaves some time for questions.
Thank you so much, Matthew. And there was so much information in there, and it's every time we hear from experts, it opens up even more questions in my mind. But thank you so much.
All right.
David has posted a question in the chat around British manufactured air source heat pumps, and he wondered whether whether there was a best one. I mean, I'm not sure if you could even comment on that, but that's one of the questions.
Yeah, no, it is a good question, and I can't comment specifically. I wouldn't want to mislead anyone with out-of-date information. I know that there are British manufacturers, but I would also always rely on the expertise of specialist consultants in that respect. I do have an issue with the lack of manufacturing and productivity of our sort of UK market, particularly in terms of renewable insulation products. It's definitely a growing space, and I've no doubt that I know that Kensa do some fantastic heat pumps. Whether they're the best, I don't know. They're based in Devon and they have a good reputation. I only know that because I was pointed towards them for a project recently as someone to investigate, but I wouldn't rely on my analysis because I don't have expertise in the technical abilities of those kinds of things.
Thanks, Matthew. And I'll open questions up to attendees, but I think it can feel quite overwhelming, retrofit, and where do you start? What do you do in terms of for a homeowner or a landlord even looking to retrofit their home or start to think, where do they start? What's the first thing that they should be considering? What should they be doing?
Well, I think it's to understand what your starting point is, what the condition of the property. Let's assume it's a house, because flats creates a different set of criteria that have to be considered. But let's say it's a house that needs to be retrofitted, or the homeowner has ambition to retrofit, whether they are living in it or renting it out. You need to know what you're starting with, and some experts estimate that you can improve the performance of a house by approximately 10% simply by maintaining it properly. So filling those gaps in the eaves, the ceiling around the windows, those sorts of things, basic maintenance items. So that would be essentially establish the baseline for the performance that you need to then improve, rather than saying, okay, let's get this down to an EPC rating of B, which is all well and good, but it may not be appropriate. It may be searching for ultimate performance without looking at the optimized. So that would be the first thing to do. And the second thing to do, in my opinion, as a designer, would be to engage someone like me who has a broad understanding of all of the issues involved. What frustrates me sometimes is people go to an installer and say, I want cavity wall insulation, or go to a heat pump installer and say, I want a heat pump installed. Well, that's great. That may be part of the suite of measures that you want to aspire to over a period of time. But if you don't start with understanding what the whole house retrofit is going to look like and how it will perform, then you're likely to run into problems.
Thanks, Matthew. And I think that's a really good steer for people sort of thinking about starting the journey, because as I say, it can be incredibly overwhelming. We've got another question from David. Does PAS 2035 start to feature as a whole house retrofit standard in the private market, and should it?
Should it? Well, the framework of PAS 2035, it is designed very much for the implementation of social housing retrofit programs, and so it's sort of tailored towards imagining how we might enable that to move forward fast. Homeowners tend to have, and that means that those projects are then bound by the strict guidance of PAS 2035 and the installation guidance of PAS 2030. When it comes to my own home, would I apply those? Would I go to PAS 2035 first? No, I wouldn't. I'd go to SPAB responsible retrofit guidance, for example, because I think it offers a much more nuanced and informative framework for, PAS 2035, all those documents and those programs, we have to have a framework within which those need to operate. I totally accept that. There is no one size fits all, and I think this is where often people lose sight of the just the simple variables that we're dealing with, literally house to house on any given street. Even striving for archetypes and saying, here's how you retrofit a 1930s semi-detached house, here's how you do a 1910 arts and crafts house. You can't do that, because the modifications I was trying to hint at during the talk is that you don't know what's happened to those houses over the years. So that's part of establishing that baseline as well. So yeah, good question, David, but sorry, that's probably an unsatisfactory answer.
We've got another question from Laura. How would you establish the baseline? Do you measure the HTC, the air tightness? And what is the benefit of draft proofing compared with air tightness measures with specialist tape and others? And did you carry out an air test to compare?
Okay. There's a whole seminar on just to answer that question, Laura. Baseline, absolutely. You need to establish those metrics. Now, a lot of this is common sense. The example I gave of the homeowner with a budget of £30,000, I messaged him one day and I said, look, today's the ideal day. Grab a beer, walk around the house, put the back of your hand around each window, around each door, around every area you can. You very quickly identify where those issues are. You don't need an expert to come and tell you how bad it is at this early stage. That's part of establishing the baseline. You can identify, there's one of the graphics in my presentation where you see all of these places where air can get into a house. You feel it. You're a human being. You know where things are, where you feel discomfort within a house. So yeah, this isn't really answering the technical bit of your question, but it hopefully gives you an insight as to everyone is empowered to be able to start somewhere. If you need an air tightness test, yeah, you don't have to pay a fortune to have that done, but it might not be worth doing if you know that your house isn't particularly airtight. It is worth doing once you know you've got to a point where you want to make a big investment into a particular technology such as MVHR, which is going to require a baseline of X air changes per hour in order to be worth installing. So the baselines I'm talking about really are, firstly, start with the obvious things. Where do you feel the heat coming through particular windows? Do you need, in case of overheating, do you need to create some sort of external shade? Do you need to improve the insulation in a particular room which gets really cold? I've got a room just down here, which is an extension built in the 90s, which is terrible. It's really poorly performing. And a piece of plasterboard fell off a few months ago, and it gave me an insight into how it was built. completely changed my understanding of the construction of that. I had no reason to go poking into the walls of it, but once that it was opened up, I could see, and I got my boroscope camera out and I poked around and I realized, wow, this is actually thermalite block. It's not a cavity wall as I'd assumed. So had I gone and got the cavity wall installer out to insulate that space, he'd have turned up and said, are you having a laugh? So yes, I haven't really answered the question satisfactorily, Laura, but hopefully I've given you a light touch insight into where to start. But please follow up if you want.
Thanks, Matthew. And Georgina's asked a question. How are the effects of climate change affecting your recommendations or your clients' requests, such as extreme heat, rainfall? I mean, you know, we've got hurricanes in off season. I mean, I know that's not in the UK, but these all impact, don't they?
Yeah.
And you know, we've had heat waves across Europe, the end of
Yeah.
May, beginning of June. We've had some of the hottest weather ever in June, and along with the highest levels of rain. So yeah, it's a good question.
Yeah, it's a very good question. I mean, my recommendations are to my clients are that, you know, building regs are mediocre. I can specify a mediocre house for you if you like. But if you want a truly climate resilient house and a house that will last for another 100 years, then maybe there are ways we can do that. And there's a different way of thinking. And what I've tried to illustrate in my presentation is that different way of thinking about what we should be doing to our homes. So the effects of climate change, I mean, the illustration of 10-year-old Sam in his bedroom, we've seen record temperatures in the UK now. Are we going to see those records being broken in my lifetime? Yeah, more than likely. How do we adapt our buildings to be resilient enough to cope with that? I've given that illustration of that particular roof. What am I recommending to clients is do it if you can, because this is if you're going to do it once, do it right. And I even was chatting to a contractor a few weeks ago. He said, "Oh, I've got this client down in Chiswick, and they've got this roof extension they're doing." And I mentioned I mentioned about wood fibre insulation that you'd talked to me about, but he didn't believe me that it was going to be better performing. And I said, well, look, just show him that video from Ecological Building Supplies, because that illustrates it. There was actually someone posted on LinkedIn this morning, a Dutch building sort of physicist who has posted a video with 6 different insulation types, all with the same experiment. And it across the board, PIR, polystyrene, mineral wool, they just can't perform as well in terms of protecting occupants of buildings from overheating as natural fibers can. The best performing, I think, was hemp, which is fantastic. Hemp is something we can grow, you know, on the fields around my house, you know, swathes of it all over the country. We could be, and there are actually hemp farms now up in, I think there's one in Yorkshire, which is starting to produce some really interesting building products. It's a regenerative, renewable resource. Let's use more of it. Are clients requesting it? Very rarely. And that's makes me sad.
And this is and we're coming up to the end of the webinar, but I think, you know, if we had more time, we'd absolutely explore then how do we help you work with the sector and vice versa to start thinking about the use of different materials, because actually that's going to be crucial in the way that we reimagine our buildings and we improve the way that we live. I just don't think we've got enough time, but it might be something that we explore further down the line. Thank you so much, Matthew. It's been so interesting. As I said, we just learn so much more every time we talk to someone else. It's been really insightful and really useful, and we hope everyone that's joined us today and that everyone that views this finds it as useful as we have. So just a massive thank you for taking the time and making sure that we start to think slightly differently. It's been brilliant. So thanks everyone for joining us. This will be available on our website. But yeah, just once again, massive thank you to Matthew, to Georgina, and to Recognition Creative for getting us here today. Thanks a lot, everyone, and
Thanks for
hopefully
having me.
we'll see you all soon at some point.
Bye.
Thank you so much.
Okay, bye.
Thank you. Bye-bye. Bye.